Hi everybody, welcome to this webinar on innovation without infrastructure, where we're going to talk about research computing on AWS with RONIN. My name's Francis Dauncey. I lead the education and research solution architecture team for EMEA, and with me is Nathan Albrighton, who's the CEO of RONIN. Say hello, Nathan.
Hi everyone. Thanks so much, Francis and the team for organising this. Really looking forward to it.
Cool. Can we have the next slide, please?
Yep.
So just before I hand over to Nathan, I wanted to just give everybody a view of what this 45 minutes to an hour is going to be about. This is about science, not servers. So one of the things we want to do is help democratize research. We want to give you the ability to put a individual on-demand high-performance compute cluster in the hands of every researcher and scientist who could possibly need one. And this also allows us to help decrease the time to science. What we mean by this is when doing compute-intensive research, sometimes that research is going to take months to process because you are limited by only having 20 nodes or 40 nodes. The great thing about the AWS cloud is your resources can scale to the size of your science. So a good example of this is we have a UK customer who used 152,514 instances over 6 days in the AWS cloud. His total expenditure was $3,050. Now, if they would have done this on their on-premise solution, it would have taken them over 100 days. So that scale means that they can do research faster, and if you can do research faster, it means you can get to science faster, and you can have impact faster. But the other thing is we want to eliminate the shared resource contention. In lots of research organizations and in lots of universities, there is one or maybe two large shared cluster. And this is an oversubscribed resource, and lots of times you've got to sit in a queue to do it. So your research is ready, but you've got to sit in a queue for 2, 3, 4 weeks basically before that starts to run. With cloud, you don't have to do that. You can do massive compute-intensive research with just a few clicks. Now, I know lots of people are saying, "Oh, Francis, that don't believe you." So what we've done is we've invited Nathan along. Nathan is now going to show you how you can realize what I've spoken about through AWS and RONIN. So Nathan Albrighton, I'll hand it over to you.
Hi everyone. Thanks so much for making the time. We're really excited to show you RONIN, our platform for making research simple in the cloud. I thought I'd start today's webinar by giving you a little bit of background on myself. I am the CEO and founder of RONIN. I come up with this idea after working for a large organization of thousands of active researchers. While I was working at that organization, I was tasked with collecting requirements of those researchers as to what they need to get their research done. So collecting requirements on storage, on compute, on HPC resources, those types of things. So what we did was build a simple user interface that researchers could plug in their requirements and tell us exactly what they needed for their research. And what happened was we immediately ran out of all of our infrastructure. We ran out of storage, we ran out of CPUs, we ran out of time on our supercomputer, and we had 500 plus projects waiting for more infrastructure to turn up. And what that led me to was logging into AWS for the first time. 3.5 years ago, AWS were miles in front of other cloud platforms. They still are. They still have a very big head start on all of the services that are offered. And what I did was I logged into the AWS dashboard for the first time. It looked a lot like this. And I clicked on the services panel and I was met with an amazingly powerful set of options, but an equally horrifying learning curve that was ahead of me. Now, we had seen a lot of researchers head into the cloud and start this journey themselves. And if we're talking thousands of researchers in an organization, we're talking about many hundreds and thousands of hours of wasted brain cycles where everybody in the organization is becoming cloud certified DevOps, SysOps engineers. And we thought that that time could be better spent, and a lot of our researchers were even coming back with feedback saying They just want to focus on their research. They want this set of options to take away the issues they're having when it comes to scaling, to the speed of the processing of their data sets. So we took that feedback, we took this need, and we took the tools you see in front of you, and we built the RONIN platform. Now, before I show you how simple we made it to interact with the AWS platform for your research, I thought I'd show you a tweet that illustrated it quite well. Now, up here we have one of our founders' smallest instances, Finn, sporting his best mustard coloured cardigan, and he's launching his first 4,000 core cluster on the Intel booth at the AWS Public Sector Summit. Now, this isn't to add any pressure to those who haven't launched a supercomputer in the cloud, but this is a great way for us to show just how simple it is for us to unlock the immense power of the cloud for research. Now, what I'll do is I'll jump across to our RONIN platform and I'll log in and just show you all of the tools and all of the fun buttons to get started. Okay, so let's log into the RONIN user interface. Now, when we log into RONIN, what we land on is our project screen. Now, everything that you use and consume from the AWS platform in the background is organized by project. If I log in to a project, what we land on is the project dashboard. Now, this is a top-down view of everything that's happening in the Mars project. You can see at the very top that we have $15,000 allocated to the Mars project. We've got just over $10,000 expenditure so far. And as I consume this budget with resources from AWS, at 25, 50, 75 and 100% of the cost, I'll get emails triggered to me. Now, we want you to know at all times how you're tracking when it comes to cost. All of this here that you see is mobile friendly as well, so you can check your project budget anytime you need to from your mobile. And you can also control the resources that you have spun up for this project or any of the projects you have access to from your phone as well. So if you realize that you're running into the limit of your budget, you can actually go in and control the resources and slow down the expenditure. Now, down below this, we can see I have 0 of 1 running machines, and I have 0 of 1 running cluster nodes. Now, while my machines are stopped, I don't have to pay for the CPU and the RAM on those machines. This is a great way to game Amazon for best value, is stopping the machines that you're not using to stop paying for them. Much like your electricity, when you flick off the lights, you stop paying for the electricity. So this is a great way to game Amazon for value, and we have some great tools to help you automate this type of shutting down of resources. Below that, we have the storage rounded up. So we have 565 gigabytes of SSD storage in the Mars project right now, and that's $67.80 a month. Now, while the machines are stopped, I've got a great idea of how much cost this project incurs while it's in this resting state. We know it's about $70 a month. Okay, so now let's get into the fun stuff, creating a new research environment. If I head over to our menu on the left-hand side and I select the machines and then the new machine link in the menu, what we'll get is the RONIN create a new machine workflow. Now, we tried our hardest to make this very simple, almost a shopping cart experience that we're all very familiar with, and take away a lot of the technical jargon and a lot of the deep level cloud lingo to actually building a research environment. You'll see here at the top we've got the latest operating systems that Amazon offer and support. And then down below that we've got pre-configured software of any type of software stack that you need for your research environment. So this can be modified by the organization or by the members of a project. So for example, and for this example today, I'll select the RStudio software stack. We can see here it's actually an Ubuntu server with 1804 as the operating system, but it has all of the RStudio software pre-configured for me, ready to go. And all I need to do is consume that. So I'm looking to do some RStudio research. If we go to step number 2, the address, in here, Ronin will help me do all of the networking for this machine, which is by far one of the most difficult things to get correct in the cloud platform if you're a brand new user. So if I put in rst.ronin.cloud, Ronin will check to make sure that that is a unique subdomain for this top level domain of ronin.cloud. And it will do all of the security groups, ports, anything else that I might need to keep my machine secure. It'll do all of those networking settings for me, and all I need to do is name it something unique. When I go across to machine type, at the top we've got almost like t-shirt sizes, a small, medium and large for those who are just having a look around or trying this on for size. And down below that we have the 220 plus server sizes and configurations that Amazon offer for different types of workloads. So you can see here there is so many options for you to select something that fits your research workload or the type of job that you're trying to do in the best possible way. So if we decide that our RStudio script needs a lot of RAM to get running, we can go down and select from the memory optimized machines a machine with, say, 1/4 terabyte of RAM. On the right hand side you can see, much like a shopping cart, it's starting to fill up with our options that we've selected. If I move across to storage, we wanted this to feel like you were shopping for hard drives. So we have a little bit more information in here so that you can see how much this will cost as well if you select any of these hard drives. So at the top we've got some recommendations on what type of storage at what size is good value. And then down below that we have the families of storage. So in this case I know that 100 gig of SSD is $12 per month, so I can add 100 gig drive of SSD to that and my shopping cart gets updated on the right hand side. Now that we have everything we need to launch the machine, all I need to do is hit the little rocket here for launch, and we get our key management modal drop down. If we need a brand new key, we can quickly create one. We can also upload one if we have a key on our desktop. But for this demo, what I'll do is I'll just use a key that I already have on my desktop. And here it is. And if I hit launch my machine, so within 4 minutes or so, we'll be able to log into this RStudio environment and begin our RStudio research. Okay, so let's go across to the machine summary page and have a look at the machine we just created. You can see here on the left the rst.ronin.cloud machine that we just created is already up and running and ready for us to log in and begin our research. On this card we'll be able to see the networking information, the ports that are open, the person who last interacted with or created the machine. We'll be able to see the specifications of the machine we selected. We can also edit this machine if we decide that this is too large or too small later on as we learn how our workflow behaves on this machine. We've got our storage and specifications below that as well, and on the right hand side we have that stopped machine that was reporting back in our dashboard earlier in the demo. Now if I go up to the top and click on the costs tab here for our monthly costs, what we get is a breakdown of all of the infrastructure we're running in the AWS platform and how much each item is costing us, so an itemized breakdown. Now on the left we can see that the running R4 8X large machine that we have is $1,800 a month if it's running 24/7. If it's stopped, it costs us $0 per month. For the actual server, we're only paying for the storage. So this is really easy to illustrate here. When you stop your machines, you stop paying for the most expensive part of the machine. So to help you take advantage of this element of cloud computing, what we do is we give you a little alert telling you that this machine could be much cheaper. If I click this element, what we get is our Smart Schedule tools. Now, scheduling a machine is usually a complicated process with a lot of technical hurdles involved. Usually you have to get API access, you need to program something, you need scheduled jobs to be running outside of this system, and usually tuning that is too high or too much of a technical bar to jump over to take advantage of this type of scheduling in a cloud platform. Now what we've done is we've made it a simple single-click process that at the top, if I choose one of our templates, the say all business, this will schedule this machine to start every day at 9 a.m. and shut down every day at 5 p.m. Now just by enabling this schedule, our machine goes from $1,800 per month to $600 per month. So a 66% cost saving. If we scroll down and we tune this in further, say I'm not conscientious enough to work weekends and my Mondays I spend emptying my inbox and attending meetings. Now we have a schedule in here from Tuesday to Friday, 9 till 5, and for those hours we're looking at $355 per month instead of $1,800 per month for this machine. In a really simple way, if we just hit Save Changes, this machine is now scheduled to make sure that those guardrails on cost are enforced, and this machine is now scheduled. Now you'll see here those scheduled costs are also reflected in the cost tab back on the dashboard, and that means that you can get really accurate estimates that you can submit for your grant proposal to get your grant approved by the organization that you work for. You can actually create the infrastructure within the RONIN platform within a couple of minutes, all of the machines that you might need at the specifications you need. You can schedule those machines and you can get an accurate costing out to submit for your grant proposal. Now, if we go to the next tab, we can see the scheduled times and we can edit them. So if we have a job that we plan to run on Thursday and it needs to run for multiple days in a row, we can go and edit the schedule on this machine and turn off the schedule if we need to make sure that the shutdown command doesn't interrupt our workflow. Now, on the last tab of each machine, you'll find all of the tools we built to make living with these research environments a much easier process. At the top, we have Check Networking. Now, if you click Check Networking, what it will do is make sure that this machine's address is known and is resolving as a DNS address on the internet, and it will help you troubleshoot any of the connectivity problems you might be having. On Package Machine, what we can do is package up this whole operating system and software stack and make it a reusable software catalog item for the other team members in your research team. So if you've already installed the software stack that you need for your research, if you've already got your code installed and you want to share that environment, instead of sharing a key and letting other people log into your research environment, what you can do is draw a line around them, this package, and create them a reusable environment that is an exact clone of the research environment you're using. So to do this, all we would need to do is say, my clever studio software, all of our packages included. We choose an avatar to keep the user interface pretty, so we're doing something to do with rocket thrusters in our research. And then down below this we decide what gets included in that package. So we might decide to only send the root volume by excluding the extra hard drive on this machine. But if we want the whole package to go, we just make sure all of the drives are included and we hit Create Machine Package. Now that's all there is to creating a reusable, customized research environment in RONIN that users can select from when they run through the Create Machine workflow that we showed earlier in the demo. Now below that as well, we have managing backups. So being able to back up your software or your drives at any point in time. So we've made that a nice easy process where you just give your backup a name. We'll call this safe. And without you having to know it, we back up that drive. It goes to 3 different data centers. It's 11 nines of durable, and we do all of these best practice things that you didn't have to learn about. We keep your data very safe with your backups. If I close on there and we go to manage storage, we help you plug in your data sets, unplug your data sets, move your data sets around, go parallel, all of that sort of stuff, and we make it feel like a workflow that's more akin to these machines sitting on your desktop. So if I need to attach a project drive or a data set, I can come into my project drives and I can say, look, I want this 100 gig data set attached to this machine, and that's how simple it is. Just attach the drive, and when we hit close on this manage storage, that machine will refresh and it will show that this drive is now plugged into this machine for me to work on. When you're working across multiple machines for multiple steps in your pipeline, instead of copying the data, say if you had 16 terabytes of data set, instead of copying that multiple times and waiting multiple days for those copies to complete, you can just unplug them from one and plug them into the next and start your next step of your workflow immediately. If I go back to the tools, we've seen the smart schedule. This is where we actually get to it in our normal day-to-day for modifying the schedule on this machine. And then if we go to terminate machine, this is where we can actually clean up all of the things that we're done with. So things that we don't need anymore. So if I was to clean up this machine, it gives me an option to keep some of the drives before we actually delete this machine. So in here, the 100 gig SSD that we attached, it's already marked as keep on termination because it was a project drive before this. But if we decide that the 50 gig drive here as well needs to be saved, we can just click keep on termination, and then we can terminate the machine, and in the background Ronin will go and clean up the 15 different places that machine exists to make sure we aren't bleeding our research funding on parts of machines that we're not using for our research here. So now that we've cleaned up our RStudio machine, we've only got our one machine here and it's running for us. Okay, so the next hardest thing to do after you've successfully architected a brand new research environment in the cloud is to use it. And we noticed this with researchers. We noticed it while we were doing workshops for large amounts of researchers. We would show them how to build something with no technical knowledge involved, and then we had to come back after lunch and learn terminal commands that were as long as your arm. So what we did is we built a desktop tool that we call Ronin Link. Now when I click the button at the top, what this will do is open my desktop application Ronin Link, and it will find the key that I selected for this machine. It'll check that machine's available, and it will create a management card in that application for me. So rst.ronin.cloud is now available to me. So if I bring up the Ronin user interface behind it so you can see. Now for this machine, if I wanted to log into it, all I need to do is click the terminal icon, and I have a public-private key encrypted terminal that is brought up for me so that I can immediately start checking and installing binaries on this system. So we can see the storage that we have attached, we can see the drives, the mount points, all that sort of stuff, and we can start to install software on this machine if we need to modify it. Now, beyond this though, if we just wanted to use the RStudio software on our very powerful machine that we're running, what we can do is click on the tools, machine tools, and click on link to my desktop. Now in here you'll see an option for RStudio. If we click link and we put in our desktop password, what Ronin will do is set up an encrypted port tunnel to this machine, and it will open the next Chrome tab for me, and it will load the RStudio IDE into that Chrome tab for me. So in here on the RStudio machine, we also have Shiny Server that's pre-configured. And if I go across to the RStudio tab, in just a couple of seconds, we will have the RStudio IDE load up for us, and we can begin our RStudio code directly from here. So we like to say, especially when we do our workshops, this is the type of thing that we do in a workshop. This Chrome tab has 1/4 TB of RAM plugged into it. When you have RStudio running on your desktop, you can cut and paste your RStudio code from your desktop into this IDE, and then you can run it at a scale that you've not been able to when you're reaching the edges of the, say, 16 gig of RAM and the 8 cores of processing power your laptop has. This helps you take it well beyond what you could get out of that laptop once you've outgrown that laptop. So if we wanted to then close this down, so we've got our code, we've run our code, and now I want to make sure it's all secure again, all I need to do is go back and remove that link. Now that that port tunnel has been closed down, the link to this machine has been terminated and it's all completely locked down again, waiting for a public-private key handshake that only I have the key to. So that's how we make interacting with your research environment a much simpler process too, without having to compromise on any of the security of your machines. Loads of our researchers have government partnerships, they have medical data, they have sensitive data sets of all sorts in here, and we need to make sure that that's as protected as it possibly can be while still being easy to use. We still want to make sure we make the most seamless experience for you when you're logging into Ronin and when you're using our research environments. Now what we'll do is we'll move across to our Autoscaling Clusters tool. Now if we go to the left-hand menu and we select the Autoscale Clusters menu item, what we get is our Autoscaling Clusters summary page. Now I already have a cluster that I created earlier, so I'll just start that one. And we'll get that ready so I can log into it towards the end of this demo. Now if I go across to the new Autoscaling Cluster button and I click here, we get our Autoscaling Cluster Tools drop down. Now we've made this as simple as we possibly can. It's almost as simple as launching a single machine. The process for launching a supercomputer on AWS with Ronin. And if we go through these steps, I'll just show you how simple that can be. If I select my favorite operating system up the top here, and then I select my favorite scheduler, just like in a single machine, if I select the name of my cluster, Ronin will do all of the networking for me on this. So we will going with the London theme. Now if I scroll down a little bit further, we can define the size of the machines involved in this HPC environment. So for our master node, I can select, say, a machine that's large enough to run the queue, the Slurm scheduler, and for me to log into. So I'll just select a large general purpose machine for that. If I go across to step number 5 and select our compute nodes, this is where it gets really interesting. Those 220 plus server sizes and configurations I mentioned earlier are now what I can build my supercomputer out of. So if I'm submitting jobs that I know only need 8 cores of processing power, I can actually search for or select machines that have 8 cores and make sure I get 100% utilization of the cores that I'm paying for. So you can build a supercomputer here that suits your workload exactly and make sure that you're only ever paying for cores that are doing research workloads for you. If I go down and I select, say, these are the latest Intel offerings at this point in time. And if I just grab one of the C5, we'll go C5 9 large. They've got 36 CPUs. They're the latest Intel architecture available on the AWS platform. If I select them, that will be our compute nodes. So these will be the compute nodes that do the heavy lifting of taking jobs from my supercomputer queue and processing them for me. Each machine has 72 gig of RAM as well. Now, below that, we have a place for you to define your application storage. So this is where you define how much space you need to install your applications. So what I'll do is I'll up that to 50 gig of SSD, so I've got a place to install my software. And when it comes to shared storage, this is your working space. So how much space do I need to work on the files or the data sets that I have that I plan on processing with this HPC environment? I'll make that 200 gig for this demo, and then we'll go down a little bit further and we will select a key. So again, we manage the access to this machine. I'll select the same key that I used for our demo earlier with our RStudio instance. When I get to step 9, this is where we define the auto-scaling parameters of this cluster. So when you build a supercomputer in the cloud, you want to do it in a cloud way. You don't want every single node to be spun up immediately because you'll be paying for it from that time that you spin it up. So what we want it to do is to, first of all, when it's launched, be at its minimum possible capacity. Now in this case here, we default to 1. So when we launch this cluster, it'll only have 1 compute node because we want the cost to be at its minimum if it's not doing anything. For maximum machines though, we'll define that it's allowed to scale up to 120 of these C5 instances that we've selected up here. And that'll be what it can scale to as its maximum capacity. So this is our way of putting a limit on only go up to 120 of these compute nodes for me. Now, with that, if I skip down to step 11, you'll see that we've started to do some of the math on that for you. So you can get an idea of what this looks like at its minimum and its maximum. If I launch this cluster right now, it'll cost me $2.12 per hour. It'll have 38 CPUs and 80 gig of RAM because when I launch it, it won't have any jobs in the queue. It won't be busy doing my research workload. This cluster though has the potential to scale out to $240 an hour. But at that stage, it'll have 4,300 vCPUs worth of power, and it'll have 8 terabytes of RAM, or thereabouts. What's great about this is not a shared resource. It will scale up and scale down, and it will perform the workloads that I submit to it, and only the work that I submit to it. So in this environment, especially for dev cycles, we can cut down your dev cycles a great deal if you're used to submitting your code to say a national facility or a shared facility on site where you have to wait hours or days or sometimes even weeks for your code to run. In this, what we can do is run your code immediately, let you change your code hundreds or thousands of times a day, and then when you need to use one of those national facilities, you've got much more confidence that your code is correct because you got to try it many, many more times. Now, below this, we do some example workloads, and we show you what that cluster could cost you, just so you've got a good idea about where this could go and how you can plan for this to fit in your research budget. Now, the prices we're looking at here are all on-demand prices, and what I mean by that is if we look at our step number 10 of use the Amazon spot market, Amazon ask $2 per hour for the C5 instance that we've selected here. So that's the retail price for that instance type. Now, what we can do with a click of a button is put in a cheeky bid of much lower than list price, and we can ask for them to use spot instances for our cluster. Now, to quickly explain the spot market, Amazon, to keep the cost down on all of the spare infrastructure they have available, they offer this spare infrastructure up as spot market in a bidding system that you can put in a bid that is lower than cost price. And if you're above the price that those instances are going for on the day, you'll get them at that lower price. So you can see the effect on your actual cluster, especially if you've got a large workload happening. You can make significant savings in here on the actual machines that you're paying for. Now, because and to give you an idea of how much of a workload this is down here, this is showing in our Relentless Use Case. This is calculated on 353,000 vCPU hours per week. So it will be a 20 grand a week machine, but we're talking about an immense amount of processing and an immense amount of vCPU hours. Now, because I know this cluster will only be $2.12 when I launch it, it's not as horrifying to me to actually launch this 4,000 core capable cluster down the bottom. Now, that's all there is to building a HPC environment with Ronin. If I click Return to Cluster Summary, we will see the progress of that cluster build, and that cluster will be available within 8 minutes. Now, because I don't want to have to wait 8 minutes for this demo, I've already fired up the London cluster right next to it. So what we'll do is we'll log into that one. All of the tools that we explained in the single machine are available on the clusters as well on your HPC environments. So you can schedule them, you can check their cost, you can use the storage management features, the smart schedule, the backups, and you can package up your HPC environment, which is an amazing advantage when it comes to building really complex environments and sharing them. Now if I go back to the info panel and I click Open with Ronin Link, it will launch the Ronin Link desktop application for me again. It will find the key and it will create me a desktop management card. Now, we did build this desktop application for Windows, Mac and Linux, so we should have you covered there. And if I select the terminal, what we have is a terminal that logs me into the head node on that machine. So if I just shuffle my windows around a little bit, I'll put the London cluster in the background, and we can watch the other cluster be built. So now that I'm logged in, I can do a quick check of the storage, and we can see that our apps directory and our shared directory are there for us to copy our data sets and install our software. Now, when it comes to installing software, we actually partnered with a company called SPAC, so S-P-A-C-K, and if I just run a SPAC command, SPAC list, what we can see here is the 3,500 applications that are available for us to install with a 3-word command. So we wanted to make sure that when you built your cluster, it was really easy for you to configure your software and then copy your research and then get started with it. So we wanted to make sure that those processes were available in as easy a possible way that we could provide them. So for example, if I go SPAC list and I go say open foam, that will search this list and let me know how many packages have OpenFoam in the title. If I want to install OpenFoam, I can just go SPAC install OpenFoam. Now, normally installing OpenFoam is a bit of a journey. There are a lot of dependencies, there are a lot of things that you need to get right. Now, what's happening in the background is SPAC is finding all of the dependencies of OpenFoam, and it is installing them in the order that they're required. So all of those dependencies will be installed first, and then OpenFoam will be installed and configured, ready for me to use directly in my scripts. Now, that'll take a little while to install. So what I'll do is I'll jump back to my Ronin link. So I can leave this one running. I can just close this one down. And I can show you some of the other tools we built in. So much like our RStudio link that we did in our single machine demo, we can actually link to the desktop the HPC performance monitoring tools, Ganglia. So if I click Ganglia here and I put in my desktop password, Ronin Link will set up a port tunnel to the head node of this cluster, and it will show me the performance of this cluster. All of the compute nodes are reporting back to this head node here, and we can actually check to see, you can see where I started this cluster earlier in the demo. You can see where the compute node come online and added itself to the pool of resources. If I scroll down further, we can actually see how each compute node is performing. So we can see, we can go down here and we can troubleshoot, jobs that have hung. We can check to see how jobs are performing, or if they're running out of memory or compute as they're being run on these compute nodes that are dynamic. We can also see how it's scaling here. So right now, because this machine hasn't got any workload in the queue, it's at its minimum possible capacity, which is one master node and one compute node. Now, when we submit jobs to this queue, we will watch these compute nodes burst into existence, process jobs, and then burst back out of existence as soon as those jobs are finished. And that's one of the most efficient ways to doing HPC on the cloud. So once I'm done here, and once I'm happy with how the cluster's performing, I can just remove that link and lock everything back down so that the cluster will only respond to me and my private key, and that just means that we've locked down access to the Ganglia side again. So if I go back to our platform, we will almost have our brand new cluster available. We just need to wait for the compute fleet to report back. Now, a great way to have a cluster is having a cluster that is stopped waiting for you to use it. So just like in single instances, if you stop your cluster, you stop paying for all of the CPUs and all of the RAM of that cluster. So once this cluster stops, I'll be able to show you what that sort of cost looks like in the dashboard. So now that that cluster has stopped, what you can see here is for the head node, which is a T3 large, we're paying $0 per month because it's not on at the moment. The C59X large, we're not paying for it either because it's not on at the moment. So right now, for a cluster with 200 gig of SSD that only does workloads that I submit to it, it's not a shared resource, I only pay $33 per month in storage for this cluster, just to have the privilege of having an incredibly powerful 4,000 core capable resource available when I need it. If I need it again, I can hit the rocket and start this cluster again, and it will return to exactly the state it was in when it stopped, and I can start my workload again. So you can build out an arsenal of extremely powerful tools when it comes to HPC for your research, and you can have them all stopped here waiting for you for very minimal cost. On that as well, like we mentioned with the single instances, we have our schedule, our smart schedule, which you can enable. So if you have workloads, just say you have a backlog of geosat images that you need to clean up on the weekends, and you've got a spot instance cluster that will fire itself up on the weekends, process as many of those images as it possibly can, and then turn itself off for the week. You can actually schedule these machines to behave this way. And then on the end here, we can do all of those nice things that we showed on the single machine, like checking your networking, managing your backups, manage your storage, and terminate this cluster if required. So once you're done with a cluster, we can actually terminate it. We also want you to feel free to experiment in here, because that is part of research. We want you to be able to build, write commands, and then if the machine stops responding, or if you ruin that whole stack, we want you to be able to stop, terminate that cluster, build another one, and get back on your feet as quickly as possible. We want those iterations to be quicker. We want you to fail quick. We want you to learn quick and recover from that. The more iterations of this we get done, the more science, the more outcomes, the more we learn. If we go back to our info panel, our cluster should be almost complete, and very soon we will get a green report where we can log into that cluster that we created earlier in the demo. So I think it's in its final stages now. And here we go. Our TIMS cluster is up and running. It's running one of a possible 120 compute nodes. You can see who launched it. We can see all of the networking address information. We can see the storage configuration. And if we want to log into that machine, we just click the top link here, open with Ronin link. And we can start configuring that system for the next step in our HPC workload. If you're joining us today, assessing Ronin or assessing AWS for your research organization or your university, what we've also got in here is a range of administration tools to make sure you can keep a handle on everything that's happening for your organization. So everything that's happening in the Ronin platform and therefore on the AWS platform in the background. If you go up to the left-hand side, you'll note we have this Ronin admin tools section. And in here we have a range of admin tools to keep a handle on everything that's happening in your organization. So if I jump onto the budget management link, what we get is a top-down view of all of the budgets across hundreds or thousands of active projects in my organization. I can see that we planned to budget $77,000 across all of our projects. I can see that we've spent $53,000 of those budgets, and we have $23,000 remaining. I can also see a breakdown of every project below that, so how each individual project is tracking, and I can also contact project owners directly from this panel here. Now we also have on the right hand side a pause button. Now we put this in to give you an extra layer of control. If you've created a project that has a small budget, say you've assigned $100 to a project, and you note that inside that project we have machines that are a few $1,000s a month running. Now what we can do on the right hand side is contact the project owners, and we can ask them what they plan to do, or are they only planning to use it for a few hours. But if we can't contact them, instead of letting that become a procurement issue for the future, what we can do is hit pause on that project. Now when we hit pause, what that'll do is stop all of the clusters and all of the single machines running. It'll protect all of the storage and all of the data assets that are at rest, so things like snapshots, EBS volumes or storage, S3 storage and Glacier storage in the background. It'll make sure that that's all protected, but it's all frozen in place. It'll make all of the users of that project, it'll reduce them to view-only access, and it will put a big banner at the top of the project showing that this project is now paused and you need to contact the central IT administrators to resolve this issue, to have this project started again. So we've just added that in to make sure you don't only have full visibility of everything that's happening in this platform and across all of your projects, but you also have a layer of control to make sure that things don't get out of hand when it comes to the consumption of the AWS services underneath. Now, in our admin panel, we also have a range of other tools. So we have our service catalog. Now, this is where you define the service catalog offerings that you make available in the Ronin platform. So to give you an example, here we have our Docker and RStudio instance from earlier demos. Now, we can disable these packages and we can publish these packages directly from here to make sure that we can provide complex software stacks as consumable items to everyone in the organization. We have extended this to our HPC offerings as well. So you can store cold images of supercomputing frameworks and you can make them consumable items for your researchers. So they can self-serve complex architectures that your HPC team or your specialist have put together, and they can benefit from the clever work that that team have done, all in a very simple way. We also have a user administration tab so that you can add and remove users from multiple projects all in a single click. You can also see what projects people have access to and quickly add them or remove them. And you can also see how your license is tracking. At the top we have our machine list. Now, this one here sums up all of the machines that are running on both clusters and on single instances. And it gives you an idea of how much you're spending in the organization right now. So your hourly rate for the compute resources that are currently spun up. If we click on the running, it'll filter the table below for running machines. And then I can go through and check to see who has the largest machine running and just check to see if they're getting good value out of these things. So if you need to actually check that your researchers are using the correct machine for the correct job that they're trying to get done, you can see in here who's running the largest machines and who's running the smallest machines, and you can reach out to those researchers to see if they're getting great value for this. If they're only using a couple of CPUs on a 32 CPU machine, there's two paths we can take. We could help them get their code to take advantage of the size of the machine that they're currently on, or we could reduce it to make sure that the cost is reduced at the same time. So these tools just help keep things under control. And with that, I believe I'm completely out of time, so I'll just quickly hand back to Francis and thank everyone for joining this webinar today. It's been great fun explaining everything that we do with Ronin, and hopefully I'll hear from you soon.
I was going to say thank you very much for your time, Nathan. That was superb. I'd like to say to everybody on the audience, because this is going to be a global webinar, I can't give out contact details because they're going to be different in each country. So what I would advise is, if this was of interest, please don't hesitate to contact your local AWS account representative and say, please tell me more about Ronin. On that note, I'd like to thank everybody for their time, and hopefully I'll see you soon. Thank you.